Good morning. Welcome back. If you wouldn't mind opening up your textbooks to the pages from yesterday. I'm going to be, like I did yesterday, I'm going to be working on this slideshow, and you're going to be following along in your book. Let me show you the pages I want you to look at. The assignment from yesterday. It's the page that says lesson 15, all, some, or no solutions. And we're going to look at 15.2 again. Okay, and we're going to get started. We were looking at all, some, or no solutions. Yesterday, we actually got this all sorted out. We had n was equal to n. I'm just going to get this set up while we are working. V plus 2 equals V minus 2. This one was also no solutions. So this is what we left off with yesterday. I'm going to put this above here so that you can see the whole thing if you're in class. So we were looking at all versus no solutions yesterday. Well, then you will have to follow along on the slideshow if you do not have your text. Where did I put the remote? Is right here. Here we go. Sorry, guys, we're just getting up and running. Here we go. There we are. So we talked about all versus no solutions versus infinitely many solutions. So infinitely many or no solutions, if we remember, is when we have an equation where there are no values that you can plug into the equation that make it true. So you're never going to be able to plug a number in and have something equal something and have it be true. The x values or our variables are the same on both sides, but the constants are different. So we had 5x plus 4 is equal to 6 plus 5x. Our variables are the same here, but our constants are different. We have a plus 4 and a plus 6. Does everybody remember that from yesterday? Wonderful. That is sort of I like to call it the opposite of infinitely many solutions, because in infinitely many solutions, any number that you plug into an equation will make it true. So the x values and the constants are the same on both sides. So we said the example of 5x plus 4 is equal to 4 plus 5x. We could say 1/3 x plus 2 is equal to 2 plus 1/3 x. Right? So we have the same thing on each side. What we need to remember before we make these decisions here, these are last minute decisions. You don't just look at an equation. If you're given a complex equation, you're not just going to look at it and say infinitely many or no solutions. No, you're going to solve it all the way till first, like you solve it. And then once you have x's on both sides and constants on both sides, you can look at it. Or you can solve it till you get to x, okay? You can solve it all the way. So you can't just look at it and say, I know right now this is infinitely many. Well, sometimes you can do that, but most of the time you're going to have to do something to the equation, get rid of parentheses, get rid of division, get rid of something to simplify it and see if they are the same. So we did this activity in class yesterday. We were actually able to complete it. If you didn't have it written down in your book from yesterday, or if you were not here in class or on your slides, if you wouldn't mind sorting them now. So true for all values is the same thing as, what did we call that yesterday? What did we call true for all values? What was that name that we just talked about on the last slide? Kyle? Very good. Any number you can plug in would be there, would make it equal. And what was the name that we said that we were going to write for that? Junior?
No solution.
Infinite solution. So which one is true for all values? Is infinitely many solutions. I don't know how to spell infinitely. That's infinitely many solutions. When I type it, I spell it correctly because it autocorrects, but for now, when I handwrite it, it might not be spelled right. Same thing for if you're handwriting things and you write infinitely and you don't spell it right, that's completely fine. So if we had true for no values, we called that what? Instead of having to write out true for no values, what do we call that? People at home can throw things in the chat, you know. What do you think, Kyle? No solutions. Very good. Nice job, Dave. No solutions. No solutions. Very good. So we said that what we had to do to this guy right here before we could make that decision of infinitely many solutions was we had to distribute. Just like I said, you're going to need to do some work to these before you make the decision of it has infinitely many solutions or no solutions. Does this make sense, guys? So I'm going to give you guys a second to write these down in your book in case you didn't have them written down. Everybody should have these written in for this section here. And then in our text, we're actually going to flip, because we're not going to do 2 and 3 because we're going to do 2 and 3 today. We're going to do like a different type of that today. So what I want you to do is in your textbooks, I want you to flip to what's the equation. And for people that are on the slideshows, I want you to go to slide number 5. Okay. If you need to refer back to this, please make sure that you do refer back if you didn't get all of that written. Okay. So we're looking at completing each equation so that it's true for all values. So what number could we plug into each one of these equations so that it would be true for all values? Connor, what do you think? Yes, and you were supposed to be writing them in as you went. And following along means writing it in as you go through. Kyle. Oh, you're giving me an answer? Okay. Oh, I was gonna give you time to do it. But okay, so Kyle gave us one here. So if it's equal for all values, we need to find what number we would plug in here to get it equal to our constant over here of 6. So nice job, Gwen. Nice job, Max. A 2 would fit in here. Very good. Awesome job. Now I want you to take about a minute to see if you can do B and C. So which values can you plug in for B and C so that it's equal for all values? Once you're at home and once you finish those 2, if you want to throw them in the chat, you can. Nice job, Dave. Oh, I don't see. Boom. Taking a minute. I'm actually going to turn the camera so that it's on me, even though you don't really need to see me. I just figure it might be better if you're looking at me / the board. Okay, nice job, Max. We're going to take another 30 seconds. Oh, guys, thank you for catching that. Okay, nice job. We're going to start to wrap up. We're going to get started in about 10 seconds. Which values can we plug in here so that it would be equal to it would be true for all values? So I'm going to have Sadie help me out. So we're looking for, the piece that we're looking for is our constant, right? And so it needs to be equal to what number? After we distribute, the constant needs to be equal to what number? What kind of 2? Negative 2. So it needs to be equal to negative 2. So what do we have to plug into this box here so that it's equal to negative 2 after we distribute? A positive 2? What did you think, John? You would agree? Perfect, because if we multiply a negative times a positive 2, I'm going to get a negative 2. A negative times a negative x would get me a positive x is equal to x minus 2. Because when we're dealing with solutions that are, it's true for all values, we need the constants and the variables to be equal on both sides. Awesome job. Max is going to help me out with this second one here. Max said that C is going to be equal to, for this, so C is going to be equal to 3x. How can I condense this left side a little bit? I can break it into two different parts. Yes, Kyle. And what would one of the parts be? Yep, so you would divide each of the pieces by the 5. So we could say 15x divided by 5 minus 10 divided by 5. And we can simplify that to, what would it simplify to? 3x minus 2. Because we divide 15 by 5, we get 3x. We get negative 10 divided by 5, we get negative 2 is equal to 3x minus 2. Does that make sense, guys? Wonderful, perfect. So now I'm going to give you 2 minutes to do the next slide. Actually, I'm going to give you 1 minute to do the next slide. And the next piece of this, let me just move that, sorry guys. We are going to look at, now we're looking at those same 3 equations, but we need to make it so that it's true for no values. So we're trying to find no solutions here. So what are the 3 constants or the 2 constants on A and B that I can plug in that would get me something that would be value for no solutions? And the same thing for C. I want you to take about a minute for that right now to do this piece. These 3, you want to make them equal to no solutions. No solutions, if we remember, means same x or same variable values, different constants. People at home, once you finish them up, if you want to throw them in the chat saying like A equals, and then tell me what your value would be, that would be pretty cool because I'm going to call on people as well. Wonderful. We're taking about, I'm going to say 10 more plus this. So 27 more seconds. A is equal to what, Gwen? Give me the value for A. The no solutions is a little bit easier than the infinitely many solutions. So, Kyle, what do you think? Do you want to help me with A, Kyle? Do you?
Yeah.
What did you put in that box? Or what did you put in the space?
37.
37? Okay, because if I were to distribute this 3, you picked a crazy number there, dude. We would get 3x plus 6 is equal to 3x plus, oh God, 21 plus 90 is 101. Someone check me. 111. Close. Oh, put 20. So close, Mr. Me. Okay, good. 37 works. Any number other than what number would work? 2. Positive 2. So if you had done negative 2, that would have worked. If you had done 4, 1/3, 72, all of those would have worked as long as it wasn't that 2 that made it equal to all solutions. Okay, now let's look at B here. What was the value you got for B, John?
7.
John put in 7. Let's test it out. X plus 2 is equal to -7 plus X. Very good. Nice job. That works. Fantastic. So this last one's a little bit tricky. What do we think? Connor?
I did 7x.
Okay. So let's put 7x in here. So 7x is equal to, or 7x minus 2 is equal to, we simplified that on the last slide, 3x minus 2. So would that be equal for no solutions though, or would that be equal to one solution? It would be one solution. The thing that needs to be the same, the variables need to be the same on each side. So this one here is not possible. So like this one, because we have this -2, there's no way to put one in there that would make it no solutions. Does that make sense? Connor, go ahead.
What about like just 7?
Well, if you did just 7, then it would be 5 is equal to 3x minus 2, and then you would add 2, and then divide by 3, and that would still get me a value. So this is this one is impossible to do. Well, if you plug 9 in though, Glenn, it's going to do the same thing that I just wrote here. It's going to get you equal to one value. We want to get it equal to no values. And there's no way that we can do that with this constant of -2, because the -2, the constants are the same on each side. Does that make sense? That one was a little bit tricky. That was a little bit of like a trickster question, but I think it was still a good thing to do because it gives us a little bit of practice. And just being able to notice that these things might happen where it's not going to be perfect. So now in your textbooks, if you're on your textbooks, I want you to flip to, now we're looking at lesson 16. It's called, the lesson is called How Many Solutions? And we're going to look at 16.3 first, okay? We're going to look at 16.3, and if we have time, we're going to look at 16.2. So if you're on your slides, you don't have a textbook, we're on slide number 7. If you have a textbook, we're on How Many Solutions, lesson 16. 16.3, make use of structure, okay? So for each equation, you need to determine whether it has no solutions, exactly one solution, or is true for all values of, and has infinitely many solutions. So you're deciding, does each one of these have infinitely many, no solutions, or one solution? And remember that if we have one solution, our variables are different on each side. Okay, so many solutions means we have the same variable, same constants. No solutions means same variable, different constants. And one solution, as I wrote here, means the variables are different on each side. So I'm going to give you, there's a lot of problems here. We're going to get through as many as we can. I'm going to give you 7 working minutes to look at all of these ones here. There are 15 of them, but some of them you can just look at and make the decision by looking at it. Like for the first couple, you're going to be able to make those decisions really easily, and then you're going to have to do you might have to do some solving here to see what's going to happen. So I want you to take out a piece of lined paper if you to do some of this work on. People in here, if you need paper, I can give you paper. People at home, please grab yourself a piece of paper so that you can do this work out on some paper. And I'm going to give you 7 minutes to start to look at these. And I might extend the time once we get a little bit closer. Actually, I think I will extend it. I might say, I'm going to give you 8 for right now. And then if we're still working and we're working well, then I will give you more time. Does everyone understand what I'm asking you to do? So you're looking at the next, the 7, 8, and 9, if you're on the slides, or all of them in 16.3 in your textbook. If you're in your textbook, you can come in and you can write next door to each one, write the answer. Is it going to have infinitely many solutions, no solutions, or one solution? Throw questions in the chat if you don't understand what I'm asking you to do. So your answers are going to be, let me just find some space. One solution, no solutions, or infinitely many solutions. So you can flip back to your slides and get started. I'm looking for these 3 types of answers for each one. One of those 3. Does everyone understand? Awesome. Okay. Should I start my timer? Okay, good. Hey, so my friends at home, Max, I'm going to have you give me the answer for 1B. Max, I'm going to have you do 1B. Gabe, I'm going to have you do 2A. Naseem, can I have you do 2B? Okay, I'm going to have Adam show me. I need you, Adam, in the chat. I want you to tell me the answer for 3B. Make sure you label it, 3B. Elliot, I'm going to have you do, Naseem, I'll put it in the chat. Elliot, I'm going to have you do 3C. Elliot, you're going to do 3C. Okay, I'm going to have Abby help me with 4A. I'm going to have Peyton help me with 4B. I'm going to have Cam help me with, let me see, 5A. Cindy is going to help me with 1A. So Cindy, help me with 1A. I did say 4B. Yes, Peyton. Oh, and Gwen, sorry, Gwen. Can I have Gwen? Perfect, nice job, Adam. And Gwen, can I have you do 5B? That's what I'm going to share. Okay, does that make sense? Nice job. I'm going to write those down so that I can easily pull them back up. Good, so start putting your answers in the chat. We're gonna take about 2 more minutes of work time, 2 more minutes of work time. So everybody at home, the one that I assigned you, please put your answers in the chat. Start to put that in for me. Okay, let me go back and I'm gonna write them all down so that I don't have to keep scrolling. Thanks, Gabe, for clarifying. Ian, I gave you, oh, sorry, Ian. I gave you, wait, 1, 2. Can I have you check over 5C? Check over, can you do 5C, Ian? So you guys are going to share that one and we're going to check. Because that one's probably the most challenging one. So I wanted to have 2 people do that. I'm going to. Okay, we're going to take 1 more minute. I'm going to give 1 more minute. Max, you're doing 1B, Max. Perfect. So. Oh, it was not in there. Wonderful. So once you start getting your answers, start putting them in the chats. I'm still looking for. Elliot, I'm waiting for yours. Nassim, I'm waiting for yours. Ian is finishing up. Adam is good. Nice job, Adam. I'm waiting for Elliot's and I'm waiting for Cam's. So, Oh, nice job, Naseem. Thank you. Okay, here we go. Let's take a look. Okay, so let me erase. We're going to take another look over here. We were looking at 1A, which was done by, let me see, Cindy. And Cindy gave us an answer of no solutions. Let's take a look. Let's take a look at 1A. What did we think for 1A here? Cindy said no solutions. What did you think, John?
It has one solution.
One solution. And why do you think it has one solution? Because you solved it and you had like x is equal to a number? Good. Connor, why else do we think that that would be one solution? Very good. So the variables are different on each side. We have a 6x and a 7x. So it would be one solution, everybody. One solution for that guy. Now let's take a look at 1B. 1B was done by Max, and Max said that his had infinitely many solutions. Infinitely many solutions. And let's see if we agree. What did we have to do here first before we could make that decision? I had to distribute. Very good. 2 times 3x is 6x. 2 times 4 is plus 10. So what do we think about that one? Is it going to have infinitely many solutions? Our constants are different. We have an 8 and we have a 10. So what does that mean about this type of solution we're going to have? Thank you, Elliot. Oh, 8 is 8. You're right. Oh, Mr. Mate. Thank you for catching that. Good. Infinite many solutions is correct. Sorry, guys. No. Yeah, thank you, ma'am. Mr. Mate's brain is a little bit kooky today. Now we had 1C who I gave that one to John. Which one?
No.
No solutions. Very good. And S, no solutions, because we have the same variable on each side, but a different constant. Very good. Nice job. Wonderful. Now we're going to look at 2A, which I gave to Gabe. And Gabe said that this one had infinitely many solutions. And what did I have to do here before I could make that decision that it had infinitely many solutions? I'll go ahead, Connor. I had to distribute. That means multiply 1/4 times 12, 1/4 times my x, times the 4x, and I would get, what would it simplify to? Nice job, Gabe. It would simplify to 3 minus x is equal to 3 minus x. So he was correct, infinitely many solutions. Very good. Now, when we looked at 2b, which I had Naseem do, he said that it had one solution, and that is correct. Awesome job, Naseem. That is perfect. One solution. And why is that? Because we have a negative x on the right side and a positive x on the left side. Because it's a negative on the right and a positive on the left, those are two different variable numbers. They're the same like physical number, but we also need to think about the sign. So because it was a negative on the left, on the right hand, and a positive on the left hand, it's going to be one solution. Does that make sense? That was probably like the trickster. That was probably the low-key question. Good. Awesome job, Naseem. Perfect. Now let's take a look at 2C, which I had. Did I have? Wait, who did I have do it? 2C. Nobody on this list. So did someone in here do 2C? No, let's do 2C together. 2C, we have x minus 3 is equal to x plus 3. What about this one? None? No solutions, and why do you think that?
So if you look at the equation, x minus 3 equals 3 plus x. So that's like not equal.
The constants aren't equal. Very good. On the left side, we have a negative constant, and on the right side, we have a positive constant. Does that make sense? Wonderful. Awesome job, guys. Let's take a look at the next piece of this, number 2. Number 2, we had, the second slide, 3A was done by, somebody in here? Sadie, help me out, Sadie. What did you think for this one? Infinitely many solutions. Let's test it out. So what did you have to do with this one, Sadie?
First, I come out with 5x minus 3.
Yep, and what did it combine to?
I added them.
Well, it's a negative and a negative, so it's like you add them and then so it'd be negative 8x. Very good. Plus my constant of 2 is equal to negative 8x plus 2. Very good. Nice job. We had to combine like terms. I think we had to do the same thing for 3b, which was done by Adam. And he said that we had a solution, or for 3b, we had no solutions. And the reason that we said that was because we had to combine these like terms again, and these combine to a negative 8x again. And then, but this time we're subtracting 4, and the left side is negative 8x plus 2. So we have the same variables here, but our constants are different, so there are no solutions. Awesome job on that one, Adam. Perfect. Now we did 3C, or yeah, 3C. 3C was done by Elliot, and he put his in. So he said one solution. He said that this one had one solution, and he solved it, and he got negative 4. Very good, because when we combine our like terms here, negative 4 and negative 5, we get a negative 9x minus 2 is equal to negative 8x plus 2. And because our variables are different, it's going to have one solution, which Elliot found was negative 4. Awesome job, Elliot. Wonderful. Let's take a look at 4A. Let's see who is doing 4A here. 4A was done by Abby. And Abby said that 4A had no solutions. And let's test it out. So what do we have to do here looking at this one? What operation did we have to do here? Distribute. Very good. So I had to multiply 4 times 2x to get a 8x minus 8 plus 2 is equal to 4x minus 8. And, oh no, 4x minus 8. So what is this solution going to be, really? What would we change it to? We change it to one solution, because when we distribute, Abby, if you notice, when we distributed, we got an 8x on the left side, and we got a 4x on the left side. I mean, on the right side. So we don't even have to take it any further. We don't even need to combine these like terms, because we know, because we have 2 different variables on each side, it's going to have one solution. Good, fantastic, nice job. That one was tricky. What did we have to do with B here? Distribute again. Very good. We had a 4x plus a 4x minus 6 is equal to 8x minus 1. No, minus 8, sorry. Okay, and for B, I had Peyton do, and Peyton said that it had one solution. So when we combined our so Peyton said we had one solution, let's test it. When we combine our like terms of these x's, we have an 8x minus 6 is equal to 8x minus 8. So what do we think that 4b is going to have for a solution here? What type of solution? No solution, because when we distribute here, we got a 4x plus 4x equals negative 6. We had to combine our like terms before we can make the decision. We have to combine all of our terms to get an 8x and an 8x. Our variables are going to be different, so it's going to have no solutions. Fantastic. Now we have to distribute again on this last one. 4x plus 4x. And then let me see who somebody said for this one. It's 4C. Who did it? That was Junior. What did you think for this one? Sorry, Junior. 0. So no solutions. Okay, so he said no solutions for this one. So let me continue to distribute here. 6 minus 6 is equal to 8x minus 8 plus 2. Right? Was that what you guys got? Perfect. So then we combine our like terms. We have 8x minus 6 is equal to 8x negative 8 plus 2 would get negative 6. So we would say it has infinitely many solutions because we have the same variables on each side and the same constants. So we would say infinitely many solutions. Awesome job. Last section here. We have to make use of structure again for number 5. We had, let me see, who helped me with 5A? Cam helped me with 5A, but I never got her answer. So who can help me with 5A? Let's take a look. What do we have to do here for 5A? I have to distribute. So I'm going to have an x minus 6 plus 9x is equal to 10x plus 6. So what would I have to do next here, John? I have an x and an x. I have to combine like terms. I have to combine them, bring them together. An x and a negative, an x and a 9x combines to a 10x minus 6 is equal to 10x plus 6. What do we think for this one? $10x minus 6 is equal to 10x plus 6. Sadie. Same variables on each side, different constants means what? Kyle. Somebody throw it in the chat. Connor. No solutions. Because we have a 10x and a 10x, same variable, different constant, means no solutions. Guys at home, come on, keep throwing things in the chat. You guys got this. Nice job. Let's take a look at 5B. Oh, 5B was done by, let me see. 5B was done by Gwen, and Gwen gave me an answer of infinitely many solutions. Let's test it. We have to distribute again. So we would get x minus 6 minus 9x is equal to 5 times 2 would be 10x minus 6. What's my next step here? Sadie? Nope. We're not solving. We are combining our like terms. I have an x here and an x here. What do they combine to? 10x and a negative 9x. Negative, what was it? Nope. Is it?
Yes.
No, because it's a negative times a positive is a negative, right? That's the next one. So, yes, nice catch, Gabe. It would be x plus 9x is negative 8x. Minus 6 is equal to 10x minus 6. So what would our solution be here? One solution, very good. Last one we're gonna look at. 5C. Ian, did he put, I know you did that one and Ian. So what did you say for this one, Connor? What was it? True for all solutions. And Ian said true for none. So let's test it. It is a battle royale. Let's see. Okay, so what did you have to do here? What? Distribute, very good. So I'd have an x. So we think it's maybe either infinitely many solutions or no solutions. We're gonna figure out which one. So we would do x minus 6 plus 9x is equal to, what's on the other side? What did it distribute to? Very good. And we would combine our like terms to a 10x minus 6 is equal to 10x minus 6. So what would it be? Infinitely many solutions. Very good. It would be infinitely many solutions. Do you see where you went wrong there, Ian? So what you need to do when you're solving these on the quiz, there is going to be a bunch of these, 5 of these to be exact, that you are going to be asked what kind of solution are they going to have. Please don't just look at it and make a decision. You need to do the distribution out, combine your like terms before you make a decision. You need to, nice job, Ian. We need to make sure that all of our terms, our like terms are combined before we make any decision. Please don't forget to do that. And don't forget, if you need to use a calculator to add things like negative numbers, please do it. Connor, question? Yes, fill out the little doodad, okay? Wonderful. So what we're going to do together is we're going to, actually, let me hit the back on that. I'm going to hand out to the people in here a copy of these slides, the next 2 slides. You can just fold them and tuck them into your book when you're done. So we're going to be looking at the next 2 slides. The next 2 slides are sort of a supplemental activity. Actually, we're going to look at 12 and 13. So scooch down to 12 and 13, okay? So on 12 and 13, we have to do the following. It says we have to, on the next few slides, you will have some cards with a partner or independently to start off. I want you to solve each equation, then sort them into categories. We're not going to finish this today, so don't feel like we're going to rush. We're not. You're going to sort them into 3 categories, probably by the type of solution that it gives you, but I don't know. So you're going to take your time and look at A through H, and you're going to solve them for X. You're going to take them all the way to X. I want you to, if you are at home, get a piece of white lined paper to solve these. I'm giving the last 10 minutes of class to work independently, and on Monday we will be going through these. So first you have to solve all 8 of these. Then you have to, in your textbook or on this slide, sort them into categories and give each category a characteristic. So like maybe you might say has 1 solution, has no solutions, has infinitely many solutions. That's what I'm looking for in this characteristic section here. In your textbook, that is going to go in this section right here in the 16.2. Okay? In the 16.2, you're going to sort them, and you're on a piece of paper, you're going to solve them. Does that make sense? So you're taking the last 10 minutes of class today to sort these, to solve these, and then sort them. Does everyone understand what I'm asking you to do? Before you get started, I want to go through the homework for this evening. The homework for this evening is posted in Classroom. If we look at our classroom, we have this homework assignment. And the instructions are, this evening you will have 2 Google Forms that you must complete for homework. Attached, they're both attached here. Do not hit turn in until you do both of them. You must do both of them and then hit turn in. I'm going to give you until tomorrow at midnight to complete this, okay? So you have the last 10 of class to solve these guys, and I want you to get them solved. Take some time to finish them if you don't finish them, and then the homework assignment with the 2 Google Forms. If anyone has questions, throw it in the chat. People in here, I want you to get started, and I want you to write down the homework if you're going to forget. So we have CCR after this. We're going to sort everything in our textbook into 3 categories. So we're going to do it now, and if you don't finish it, I'll finish all 8 solving them for homework, because on Monday we're going to come in right away and we're going to sort them. Okay? So if, my friends, we're going into CCR time. So we still have 5 more minutes, but after this we have CCR time. I suggest, if you're working on this, maybe you can stay in the Zoom until you finish it, and then you won't have to remember to do it on your own. Maybe you can stay in, do the homework, finish these solvings and sorts, and then we can, you can bow out, okay? Just a suggestion, but I want you guys to stay at least until 10:58. Here, I'll get you a piece of my answer. So what my suggestion is, guys, what I always do when I'm solving equations is I get a piece of paper, right? And I use the lines as like, so like maybe you can incorporate all this, just use the lines and like I want to keep everything within 1 line. You know what I mean? Try to keep it contained. Now we do a couple of things. That's just my trick. Does anybody else need a piece of white line paper? Oh, I love that you got your notebook out. Perfect. Can I move them? Yes. Let's take these and put them in the spots. So I suggest everybody at home, since you don't have anything else to be doing and you want to maybe get your homework done, you can stay in and work on these solvings and also work on the homework. But please, if you want to log out, you can. I just suggest you stay in just so that you're sort of focused.
You're going to CCR right now?
Yeah, so we're going to CCR. CCR is here with me. So if you want to work on this, you can. You don't have to do Alex today. I want you to get this done if you have to. End this video. End the recording. I'm gonna stop sharing for a moment. I'm gonna stop the recording.